Hello friends, welcome back to csap.net online training video series. Today we are going to discuss one of the important concept, right? We need to understand what are variables, reference and instances of a class, right? So as a programmer, it is very important for us to understand what are exactly variables, what are exactly references and what are instances of a class and what is the difference between them. So before starting the main concept, right, let me show you the syllabus so that you will get better idea. So in as per our syllabus, we have completed chapter 1, we have completed chapter 2, and we have also today we are going to complete chapter 3, right? If you look at the course syllabus, then you will understand the chapter 3 is nothing but the oops concept, right? And in our last video we have discussed extension methods, and whatever mentioned here from 1 to 34, every concept we have covered. And today is the last part of our oops concept, that is variable reference and instances of a class. And in our next video onwards, I'm going to start exception handling. And guys, whatever I'm showing in this syllabus, every concept I'm going to cover, right? I'm going to cover exception handling, I'm going to cover delegates, I'm going to cover multi-threading, every concept, right? Multi-threading means whatever sub-chapter I'm mentioning here, every concept I'm going to explain, right? So because this is not a basic C# course, right? This is a advanced C# course. Every concept what I mentioned in the course syllabus, right? Everything I'm going to cover as part of this syllabus, right? We will understand the reflection, we'll understand file handling, right? We'll understand the collection framework, right? In collection framework, you can see 33 chapters are there. You will understand asynchronous programming, because if you are developing or working with any kind of real-time applications, if you are developing or working with any kind of APIs, then asynchronous programming plays an important role, right? Parallel programming we will understand, right? If we want to improve the performance of our application, right, then we need to understand and we need to use this concept called parallel programming. Automapper, it is a very important and useful feature provided by .NET, right? If you are going to work with any kind of a real-time application and if you want to map the data from one layer to another layer, then automapper plays an important role. This optional parameter indexer enums we are going to discuss. We are going to ADO.NET, right? In detail, right? I will show you how to work with the SQL Server database, how to work with MySQL database, how to work with the Oracle database. All these things I'm going to cover. Then I will discuss .NET Framework architecture, right? If you are an experienced developer, then understanding the .NET Framework architecture is important. So this chapter 15 is specifically designed to uh, cover the .NET Framework architecture. Then as we become, if you want to become professional developer, then you need to update yourself based on the new features introduced in each version, right? So we'll discuss what are the new features introduced in C# 7, C# 8, C# 9 and C# 10. Then and working with XML and JSON data, we'll cover how to work with XML data, how to work with JSON data, how to convert our .NET type to a XML type, how to convert our .NET type to a JSON type. Again, how we'll convert JSON type to our .NET object, right? Then we'll discuss entity framework. In entity framework, I'm going to cover only two approaches, right? I'm going to discuss database first approach, I'm going to discuss code first approach. So another approach is there, model first, which I'm not going to cover as part of this course syllabus. Then you can see the link query, right? It is a must thing. If you are working with any kind of real-time application, then understanding the link query is important. So I'm going to cover the link query in detail. So you can see the number of a chapter in link query is 65, and it might be increased when I will start the video on this concept, right? So but for now, I listed the things what I'm going to cover. Then I will cover solid design principle and all the 23 design patterns. So this design pattern means you can see creational design pattern, you can see structural design pattern, you can see behavioral design pattern. Apart from this, I'm going to discuss dependency injection, a repository design pattern, and one thing I have not mentioned here, that is inversion of control, that is IOC container. That is also I'm going to cover as part of this course syllabus, right? Then I will discuss the most frequently asked interview question, and these interview questions are based on my experience, right? So I'm taking interviews, I'm also giving interviews in my past 10 years, right? So based on my experience, I'm categorizing that these are the most frequently asked interview question, and after this we will end our course syllabus, right? So as part of this course syllabus, we are not only going to cover C# basic concept, right? basic concept, but also we are going to cover the advanced concept like automapper, like parallel programming, asynchronous programming, multi-threading, reflection, Lenquio, Entity Framework, IDEO.NET, right? Design pattern, solid principle, all these things we are going to cover, not only in the basic, right? I'm going to cover every concept in detail. This is the reason why you can see the videos length is might be higher, but if you watch the videos from the starting to ending, then definitely you will learn the concept in detail, right? So this is what our course planning. Okay, now let us move to our main topic. So today we are going to discuss this thing. What is the difference between variables, reference, and instances of a class? Right. So sometimes you will see that some people are saying this is a variable, sometimes people are saying this is an instance of a class, sometimes people are saying this is a reference. So that means the meaning, if you look, so all are going to be used for the same purpose, right? So we need to understand what is exactly all these concepts are, right? So we need to understand those things in detail. So what is exactly a variable, what is exactly a reference, and what is exactly an instance? So without wasting too much time, let's start today's session, right? So let's start today's session. So what is a variable? A variable means it is a copy of a class which is not initialized. What it means? Suppose we are creating one variable of a class, means it is a copy of a class which is not initialized. For example, if I'm creating something like this, example A, then we can say it is a variable. So it is a variable. Variable means it is a copy of a class which is not initialized. You can see the variable E is declared but never used. That means it's a uninitialized variable. Now, the second point, instance of a class. A copy of the class that is initialized by using the new keyword which has its own memory and is never shared with another instance. So what is an instance means? Suppose I am creating like this example E2 equals to new example. So this is nothing but your instance, right? So this is nothing but your instance. Instance means it is initialized with the new keyword. So it is a copy of the class, but it is initialized by using the new keyword. And whenever you create an instance means it is having its own memory location. And that memory location is never going to be shared with other instances, right? So how it is not going to be shared with other instances, how its memory allocation will be done, that we will discuss as part of this video, right? The next is reference of a class. Reference of a class means if you are creating, it is also a copy of a class, but it is not initialized using the new keyword, rather it is initializing with another variable which is already created. So it is created by using the existing instance. You can simply speaking, a variable, a copy of a variable which is initialized with an existing instance. In this case, E2 is an existing instance. For E2, memory allocation is there, but for E3, memory allocation will not be there. It is created using this E2 instance, or you can say reference variable are nothing but a pointer which is pointing to an existing variable, existing instance. So you can see a copy of a class that is initialized by using an existing instance, and reference of a class will not have any memory allocation. In this case, this is the reference variable. This reference variable doesn't have any memory allocation. Rather, the memory allocation which is done for E2, it will point to that memory location, right? That means in this case, so the existing variable E2 and as well as this reference variable, so you can say this is not variable, you can say this existing instance and this reference variable pointing to the same memory location. We'll see all these things pictorially once we start discussing. So to simply speaking, variable means it is uninitialized. Instance means it is created using the new keyword. Reference means it is created with an existing instance. With this keep in mind, let us proceed and try to understand. So before understanding this thing in detail, first of all, we need to understand what is a class. Simply speaking, a class is a user-defined data type, right? We are saying string is a data type, but this string data type is created by using the class, right? Suppose I'm creating string. I'm creating string str equals to some data, right? I'm creating some data. So if you go to the str class, if you go to the definition, then you will see that it is a class. That means string is a user-defined data type, but string is internally is a class. That means whenever we created something class, some class, say here example is a data type. Here string is a data type. What is the difference between these two? Now this string is a built-in data type which is provided by Microsoft, and this example is a user-defined data type which is created by us. If you check both the class, then this class example is created by using the class keyword, and if you go to the string, then you will also see that this is also created using the class keyword. That means when a class is a user-defined data type, that might be a built-in class, that might be a user-defined class, right? But it is a data type. So simply speaking, data type, right? So let's see. Yeah, the second point that you need to understand is we can never consume a class directly. How to consume a class means we need to create a copy of that class. Why to create a copy of class? Let us understand. Suppose, okay, suppose I'm writing integer equals to 10. Is this statement valid? Is this statement valid? No, it is not valid. Why? It is not valid. We cannot consume integer like this. Why? Because it is only a blueprint for your particular data. This int, it is nothing but a blueprint. It doesn't have memory allocation for your data. If you want memory allocation, then you need to create like this. So here you can see it's a memory location, right? So the point that you need to remember, what is I here? Here I is a copy of int data type. In the same way, this following statement is also not valid because you cannot this string is a blueprint. You cannot store data directly inside this string. If you want to store the data, then you need to create a copy of this string. So in this example, you can see this is string, this is the blueprint, this is your data, but this data, as you can see in the above statement, we cannot store directly on the blueprint. Then what is required? We need to create a copy of that blueprint. Once we create a copy of that blueprint, then on that copy we can store our data. So what is S here? S is nothing but it is the copy of the string data type. So simply to make you understand this thing, suppose you are building a house. So to build a house, what you require? You require a plan. Can you build your house without a plan? No, it's not possible. You cannot build any house without a plan. The same thing is also happening here. Int is int and string. What you can see, int and string are nothing but the plan of your house. That means, and what are exactly I and S? I and S are nothing but your constructed house. To build a house, you will consult with an architect. The architect will give you the plan. Can you live in the plan? You go to an architect design the plan on a paper and he give that paper to you. Can you live in that paper? Can you live in that plan? No, you cannot live. So in the same way, the string and int, these are nothing but your plan. So you cannot store data directly on your plan. You cannot live on the plan. Then what you need to do? You need to construct a house based on the plan provided by the architect. And here, this I and S are nothing but your constructed house. Once you constructed the house, then you can leave your constructed house. That means you can store this 10 and hello on this I. So here, if we compare this with our example, then this I and string are nothing but your plan. Plan means it is the plan of your house. Then this this int and string are nothing but your plan, and plan means you can consider this is the plan of your house. Then this I and S are nothing but your constructed building, right? So you constructed this building based on the plan, and this 10 and hello is nothing but you, and you are staying or you are living in your constructed building. Exactly the same thing also happening here. Here, int is the plan and I is the constructed house based on the plan. So now the value 10 is nothing but you living in a constructed house, which is our example I. The house is constructed based on the plan. Plan means here integer. So the point that you need to remember is the data type is always going to be the plan, and a copy of the data type is implementation of the plan. And if you are not creating a copy of the plan, then you cannot store any data. So every class, whether it is a predefined or whether it is a user defined, is going to be a data type. So in this case, if I'm taking integer, it is data type. If I'm taking string, it is a data type. And if I'm taking example, it is also data type. So this string and int are built-in data type, while this example is a user defined data type. To consume the class, what we need to do? We need to create a copy of that class. Say, if you want to store something inside string or inside I or inside X, then you need to create a copy of your type, right? Until and unless we are not creating a copy of the class, the memory will not be allocated. And if you want to memory allocation, then you need to create a copy of the type. So with this keep in mind, let us try to understand few examples, right? So, okay, let me copy the code. So in this case, why I cannot access this variable directly? Because it's a variable. And until and unless you are not creating a copy of this class, you cannot access this directly. And the second thing is that this is a non-static variable, right? This is a non-static variable. And as we already discussed, if we want to access a non-static variable from a static block, then we cannot access the variable directly. So in this case, this main method, it is nothing but a static block. And this x variable is nothing but one non-static variable. From a static block, we cannot access the non-static variable directly. Then how we can access? Then if we want to access this x variable, then we need to create an instance of this example class. See, and if you try, then what you will get, and see what error I'm getting. An object reference is required for the non-static field method or property example.x. That means if you want to access this example class x, then you need to declare or you need to create an instance, because an object reference. So if you want to access any non-static field, any non-static method or any non-static property, then what you need? You need an object reference. And in this case, we are not creating any object reference, and hence we cannot access this. So if you want to access, first of all, you need to create an object reference of this class, and using that reference, you can access this, right? Now, how to create an object reference means we already know. So how? Now, example E equals to new example, and then by using the E, we can access this. Now, this is nothing but a copy of this class. This is nothing but a copy of the example class, and using that copy, we can access the X variable. So once we create an instance, or once you create a copy of the example class, so whatever non-static variable you have declared, they will get memory. So they will be created inside the memory. Once they got memory allocation, then you can access them like this. So this is how you can access the things, right? So the point that you need to remember is we can only print the value of x by using the instance of a class or a copy of the class, and the instance is created by using the new keyword only. If you remember, if you want to access the non-static member, then you need a copy of the class. And how you will create the copy of a class, or how you will create the object of a class, or how you will create an instance of a class means by using the new keyword only. Until and unless you are not using the new keyword, the memory allocation will not be done for the non-static variable. And until and unless the memory allocation is not done for the non-static variable, then you cannot access this. For example, if I remove this part, then you will see that this is a variable, but using this variable, we cannot access this x, because it is just a variable, but this variable is not initialized. As it is not initialized means the memory allocation is not done for the variable x. As the memory allocation is not done for the x, you cannot access this. This is the point that you need to understand. Now, let us understand what is a variable. Okay. So to understand this, so what I'm saying, now in this case, in this example, this is a variable. And as this variable means what? Now on initialized. So you can see this is a local variable, and you can see use of on initialized local variable. So here, what I'm saying, that this is a variable. So variable means, if the variable means it is a copy of a class which is not initialized. In this case, this E is nothing but a copy of the class, but this variable, this copy of this, but this copy is not initialized. As the copy of the class is not initialized, we can say it's a variable. Now, if you go to the definition, then what we have written, a copy of the class that is not initialized. And in this case, this is a copy of the class, and this copy is not initialized, and hence we cannot access this. So variable means simply on initialized variable, on initialized copy, right? So using that on initialized copy, you cannot access any member. And if you try, then you will get this error. Use of on initialized local variable is, in this case, you can see we are getting this error. Use of on assigned local variable E, right? Now what I'm going to do, I'm creating an instance. So I'm creating an instance means I'm initializing this with new example. So as soon as I initialized this E with this new example, this variable become one instance. As soon as I initialized this E with new example, this variable become an instance. And as soon as it becomes one instance, you can see I'm able to access the X. So variable means on initialized copy. Instance means initialized copy. And how you are going to initialize the copy of a class? By using the new keyword. So in this statement is a variable, and when we initialize this E with new example, it becomes an instance of that class, right? So this is a variable and this is an instance, and using instance only we can access the member. And how we are going to create the instance means by using the new keyword. Now if you run the application, then you will see that the value 10 is going to be printed on the console without giving any kind of error. Let me run the application and see the output. Yes, you can see the output 10 is printed on the console window. So this is the point that you need to remember. So we can create an instance using the following two approaches. What are the approaches? So this is one approach. You can declare the variable and you can initialize the variable. Even though you can merge the two things into a single statement. So you can also create like this, right? So in this case, we are initializing, and in this case, the instance declaration and initialization happening in one statement. And in this case, the declaration and initialization, we have split into two statements. First, we declare the variable and then we initialize the variable. And once we initialize the variable, it becomes an instance, right? And simply declaration means it's a variable, and once we initialize, it becomes instance. And in this case, the initialization and the declaration happening at the same statement, and here you can say E1 is nothing but an instance of an example class. So we have two options to create an instance. So in this case, you can see E is instance of class example, and in this case, first statement example E means E is variable of class example, and in the once the next statement is executed, E becomes an instance of the class variable, right? Now what is the difference between variable and instance of a class? So first difference we have already discussed. Now first, see, let me comment this one. So first, the difference what we discussed. Now, if we are not initialized the copy of the class, then it's a variable. But when we initialize the copy of the class using the new operator, then it becomes an instance. And using variable, we cannot access any non-static member, but using instance, we can access the non-static member. So in this case, when you declare a variable, then this variable will be having null value, and in this case, it is going to initialize the memory allocation, right? In this case, the memory allocation will be done, and in this case, there is no memory allocation, right? To understand this better, you can see this. Variable of a class are nothing but uninitialized copy of a class. They don't occupy any memory. They are holding null value. And using variable, we cannot consume the member of a class, right? So in this case, you can see example E. Here E is nothing but a variable, and in this variable, it is going to store? It is storing null value, and using this null, we cannot access the member X using variable, right? So at this point, means in this case statement you cannot access E, right? So in this statement you cannot access E, right? So in this statement you cannot access E because at this point of time this E is not initialized, and as E is not initialized, it is holding null, and using null you cannot access this value X, right? But when we initialize this with the new keyword, then this becomes an instance of the class, and as soon as it becomes an instance, you can see the next statement, it is not giving me any kind of error. So what is happening when the second statement is executed, E equals to new example? In this case, this E is going to be an instance, and as soon as this E is created with the new operator, then you will see that the memory location for the non-static variable X is created. In the previous example, in the previous statement, there is no memory allocation for the X, but in this case, the memory allocation for the X is created. Once the memory allocation for X is created, then using the instance, you can access the member X. So this is the difference between variable and a instance. Variable means on initialized copy, Instance means initialized copy. Using variable, we cannot access the member, but using instance, we can access the member. Memory allocation is not done for variable. Memory allocation is done for instances. This is the difference between your variable and you can say variable and instances. So the point that you need to remember is until and unless you initialize the variable, the memory allocation will not be done. So in this case, we are not initializing the variable, so memory allocation is not done. And when we initialize the variable, then the memory allocation is done. Once you initialize the variable using the new keyword, then the memory allocation will be done. You can see in this case, once you initialize this variable e with the new keyword, it becomes an instance and the memory allocation will be done, and then you can access the member x. So you can see here I am unable to access the member x, but here I'm able to access the variable x, right? Then, and we can initialize a variable using two ways, right? You can see by in the same statement you can declare and initialize a variable, and in this statement e becomes an instance, and the other option is first to declare the variable and then initialize the variable. And only declaration means it's a variable, and when you initialize that e with the new keyword, then this e becomes an instance of a class, right? This is the difference between variable and instance, right? Now let us understand what are references, right? Now, what is a reference? Reference means we need to understand something, right? Let me copy the code and show you the things in detail. Okay, so in this case you can see this e1, it is an instance. Again, e2 is another instance. So instance means this for e1, one memory allocation is there, right? In that memory, one copy of x variable is available. For e2, another copy of the variable, another copy of the x variable is available. That means now, as we are creating two instances, that means two copy of the x variable is available in the memory location. And instances is never going to share the data. That means if you are doing some kind of changes in e1, then that will not affect e2, and if you are going to do some kind of changes in e2, then that will not affect e1. And in this case this x variable having the default value 10. So now if I run the application, then you will see that both the cases the x value is going to be printed as 10. So you can see here x value is 10 and e2.x value is 10. Now what I'm trying to do is I'm modifying the e1 value. e1.x I'm making it as 50. So once I made these changes, and if I print the value again e2 and e1x, then in this case you will see that e1x value is going to be 50, but this e2x value is still going to be 10. Right? That means the changes what we have done into e1 memory allocation, so that changes will not reflect the e2 memory location. Right? Now let me run the application and see the output. See, e1.x is going to be 10, e2.x equals to 10. This is the first console statement, right? Then then we are just modifying the x value of e1 object. So e1 object x value we are modifying to 50, and you can see e1.x is 50, but still e2.x is going to be 10. This is fine. Now what I'm trying to do, I'm just doing another changes. What changes I'm trying to do? I'm just trying to modify the e2.x to 150. So in this case, we are modifying the e2.x. That means it will only modify the e2.x, but it will not modify e1.x. Now if you look, if you run the application, first both the variable are having 10, second e1x is 50, e2 is 10, and then third statement is still printing 50 and 150 as expected. So the point that you need to remember, instances never share the data. They never share the memory location, right? Here u1 is one instance and e2 is another instance, right? For better understanding, you can look at this memory, right? So this is what u1 object, and this u1 object first created with x value 10, and the e2 object is also created x value as 10, and this is one memory allocation and this is a separate memory allocation. Let's assume that this memory allocation is for e1 and this memory allocation is for e2, right? So both are going to be created with x value 10. Then I'm changing this e1 to 50. So e1.x 50 means it is changing this e1 to 50, right? So, but this changes doesn't reflect in e2. And in the next update statement, what I'm doing, I'm changing x of e2 to 150, and you can see x of e2 is updating to 50, but these changes will not reflect in e1. So the point that you need to understand is we can create any number of instances for your class, and for each instance a separate memory allocation will be done. In this example, I'm creating 2 instances, means 2 memory allocation is done. If I'm creating 5 instances, means 5 memory allocation will be there for the X variable, right? The memory allocation done for one instance is never going to be shared with the other instance. So this memory allocation I'm created for E1. E2 cannot access this memory allocation. And this E2 memory allocation cannot be accessed by E1. They're never going to share the memory allocation. Actually, this is the beauty of object-oriented programming, or you can say it is the security of object-oriented programming. What is the security? Now, each instance is unique itself. The changes made in one instance will not reflect in other instances. That is all about instances of a class. Now, let us talk about the references of a class in C#, right? Please have a look at the following code. So here you can see I'm creating one instance. So here E1 is an instance of the class example, and the statement to what I have written here, example E2 equals to E1. So here E2 is a reference. So here E1 is an instance of a class, but E2 is a reference of a class. See, E2 is not initialized with the new keyword, hence it is not an instance. But E2 is initialized with an existing instance. So here E2 is initialized with an existing instance. What is the existing instance? E1, right? So the point that you need to remember is whenever a copy of a class is initialized with an existing instance, then we call it a reference. So in this case, this E2 is a copy of example class, but this copy of example class is not initialized using the new keyword. Rather, it is initialized with an existing instance of the same copy, same class, right? So here example class, it is initialized with the example class copy, and whenever you create a copy of the class by taking the existing instance, then we say it as a reference, right? So here E2 is a reference. So here E2 is initialized with the existing instance of E1, and hence E2 will be a reference of the class. Simply speaking, now E2 is a pointer to E1. So here E2 doesn't have its own memory allocation, rather it is pointing to the same memory allocation which is done for E1, right? Now E1 and E2 both are consuming the same memory location, right? Now let us prove this point. Both are consuming the same memory allocation. Okay, so what we have discussed, we are just writing here. So here example, this is the instance, and here I'm creating one reference variable, right? E2, which is pointing to the existing instance. I'm here printing the value of E2 and E1 X. So what is the X value here? So it is going to print 10 and 10. So because both are pointing to the same memory location. Here I'm modifying E1.x. Even though I'm modifying E1.x, this will also modify E2.x because both E1 and E2 are pointing to X. So in this case, you will see the output is going to be 50 plus 50. So now let me run the application and show you the output so that you will get the clarity, right? So now you can see E1.x is 10, E2.x is 10, E1.x is 50, and E2.x is 50. Now what I'm trying to do, I'm just modifying the E2.x, right? E2.x I'm modifying and making it as 150, right? As soon as modify E2.x, then you will see that U1.x is also going to print the same value. Why? Because both U1 and E2 are pointing to the same memory location. You can see U1.x 50 and E2.x is also 150. So the point that you need to remember is the changes made in E1 reflect to E2, and the changes made in E2 also reflected to E1. So for better understanding, you can see, so E1 and E2 pointing to the same memory location. Initially, the memory location X value is 10. And whenever you modify the X value to 50, that is modified here, and that memory location is pointed by both the instances, and the same case in the case of 150. Simply speaking, reference of a class can be called a pointer to the instance, and every modification we perform on the member using the instance will reflect when access to the member using references and vice versa. What it means? It means if you are modifying using your references, then that will also modify the instance. And if you are doing some modification using instances, right, that will also automatically reflect the references. So using variable, we cannot access the non-static member of a class. Why? Because our variables are not initialized. As not initialized, memory allocation is not done. As memory allocation is not done, we cannot access member using variable, right? But using both instances and references, we can access the non-static member of a class. Using instances and using references, we can access the non-static members of a class. Why? Because the references is initialized with an existing instance only, and variables are never initialized, right? The references do not have their own memory location. Rather, they will pointing to an existing memory location, but references are used like instances, right? So the way we use the instances, in the same way we can use the references, but the difference between E1 and E2, or you can say the difference between the instances and the references, is that instances having its own memory location. Whenever you create an instance, a new memory location is going to be created. But whenever you create a reference, a new memory location is not going to be created. Rather, it is going to be pointing to the same memory location which is initialized with the reference, right? So that's it. That's it for today. In case you need the text version, I mean the test document, what I am showing in the presentation, in case you need, then the link for the same is provided in the video description section. Just go to that link and get the document and do the practices. And in the next video, we are going to start exception handling. Thank you. Thank you for watching the video.